This is for problem 15 on the homework, which says an alpha particle of mass 6.7 times 10 to the negative 27th kilograms and charge positive 2e is aimed directly at a gold nucleus with charge positive 79e with initial velocity 0.1 c, where c is the speed of light, which is depicted by this diagram. So the first thing I did was convert e to c, which is coulombs, and c, which is the speed of light, to meters per second. And I got 79e equals 1.264 times 10 to the negative 17th coulombs, and 2 equals 3.2 times 10 to the negative 19th coulombs, and 0.1 c equals 3.00 times 10 to the 7th meters per second. Question A asks, what is the closest that the alpha particle gets to the gold nucleus, which is depicted by this diagram. To find that, we need to find the initial potential energy as well as the final potential energy, and then we need to find the kinetic energy for both initial and final. So to find the potential energy, we first need to find voltage. So the initial voltage would be equal to 0 because the R is essentially infinity, and the final voltage is 8.99 times 10 to the 9th times 1.264 times 10 to the negative 17th over d, with d being our variable. So we plug that into the equation for potential energy, and we get 0 joules for the initial, and for the final we get 8.99 times 10 to the 9th times 1.264 times 10 to the negative 17th times 3.2 times 10 to the negative 19th over d, which comes out to 3.63627 times 10 to the negative 26 over d joules. Now we find the initial and final kinetic energy. So the initial would be 1/2 times the mass, which is 6.7 times 10 to the negative 27th kilograms, times the velocity, which is 3.00 times 10 to the 7th, and then square that, which comes out to 3.015 times 10 to the negative 12th joules. And for the final kinetic energy, it would just be 0 because the velocity is 0. So now we plug that into our final equation, which is initial kinetic energy plus initial potential energy equals final kinetic plus final potential. And the initial potential would be 0 as well as the final kinetic. So we get 3.015 times 10 to the negative 12 joules equals 3.63627 times 10 to the negative 26 over d. We solve for d and we get 1.21 times 10 to the negative 14th meters. Question B asks, what is the electric force that the gold nucleus exerts on the alpha particle at this closest approach? So for that, we just use the force equation, which is kq1q2 over r squared. And we plug in the numbers for that, and we get 249 newtons.